So to continue with what we were talking about on Tuesday with the binomial theorem expansion, with the different types of degrees that you can be dealing with, not every binomial is going to be 1 plus or 1 minus a number, okay? And the thing is that you want it to be 1 plus or 1 minus a number, because that way, when we do the expansion, we're able to get 1 to a power in every term of the expansion instead of making it more difficult. So to do that is what you see above in the right above the blue box, is that when you do have a plus bx to the n power, in other words, a represents some type of number, b represents another type of number, you basically can factor out an a from both of those terms with the respective power, so in that way it can be 1 plus b over a x to the n power. Okay? And then it will basically expand this part like you've normally been doing, and then you just multiply that coefficient through, like that one problem we did last class. Okay? This presents to you an interval of convergence for which the expansion converges for a particular interval that is less than 1. So basically from negative absolute value a over b to absolute value a over b, this is basically the x values in which this particular expansion is going to converge to one number. Okay? So like we talked about on Tuesday, is that when you have a negative exponent or a rational exponent, the sequence is going to continue on indefinitely. Okay? Which means that if you continue to add the numbers, it's going to converge to one particular number, because the numbers are getting smaller and smaller and smaller, and as you continue to add them, they're going to get closer and closer and closer to one number. Okay? And to figure out the interval in which it's going to converge to, like in between what numbers, you have this formula here. Questions? All right. So let's take a look at an example. So as we know, we can't work with the expansion of this with the square root like it is in the denominator. We're going to need to rewrite this. How can we rewrite 1 over the square root of x plus 2 plus x? Very good. The square root converts to a rational exponent of 1/2, and then of course you bring it out of the denominator by making it negative. Now this is still not in the form of 1 plus alpha x to the p over q, 1 plus x to the alpha power. Okay? There's a 2 there. You don't want that. So this is where you pull in that formula from the other page. If I were to factor out that 2, it would need to be raised to the nth power, and it's going to be 1 plus b over a x. Everybody have that? I mean, you should. It should be like right above your thing. So it should be a to the n power times 1 plus what? What would be here? What's b over a going to be? Well, technically it's 1 over 2x, but that's fine. To the negative half power. Well, I mean, that is it. So now we can actually expand it using the formulas that we talked about that were in the tan colored boxes from the last time. And then this 2 to the negative 1/2 will just get multiplied at the end after we've expanded it to the first 4 terms. Okay? So what I want you guys to do right now is I want you all, and this is to practice, making sure that you guys have this expansion, I want you guys to expand 1 plus x over 2 to the negative 1/2. I want you to expand that, and then of course we'll check it, and then we'll multiply the 2 to the negative 1/2 through at the end to get the final answer. Okay, so let's see. I'm expanding to the first 4 terms, so I got to get 4 terms of this, okay? Clearly, this is going to start off with a 1. Now it can start off with a 1 because I do have, my first term being 1, okay? Then it's going to be plus what? Alpha, negative 1/2 times x, right? Which is what? X over 2. Because it's not x in this problem, it's 1/2 x. So you got to plug that in there. Okay? Then it's plus alpha times, is it alpha minus 1 or alpha plus 1?
Minus.
So then it's going to be a minus. Got that one? What's the one that was alpha minus 1? Negative 3 over 2, all over 2 factorial. Then it's going to be x over 2 to the second power. How many terms is that? That's 3. 1 is the first term. This one here is the second. This one here is the third. So I need one more term. So that means I'm going to have to do alpha times alpha minus 1 times alpha minus 2. Negative 5 over 2 all over 3 factorial times x over 2 to the third power. Questions up to here. All I did was plug it into the formula. Okay? When I ask you guys, what's 1/2 minus 1, I should get more than just one person responding to me. That's not calculus. That is pre-algebra. Okay? Just like when I'm about to ask you now, when I'm asking you what's the product of some of these things. So I have 1, then this is going to turn into a minus. What's negative 1/2 times an x over 2? It's going to give me an x over 4, because that is technically going to be negative, but that's going to make it a minus. Over here, I'm going to have a plus. What's a negative 1/2 times a negative 3/2? That's going to be a positive 3 over 4. And then when I divide it by a 2 factorial, that's going to be 3 over 8. So now this becomes 3 over 8 times what? What's x over 2 squared? Make sure you square the top and the bottom. And now I'm going to ask you to simplify this last fraction of negative 1/2 times a negative 3/2 times a negative 5/2 all over 3 factorial. 15 over 48? Then it's going to be x to the third all over 8, right? Because it's to the third power? Okay? Then all I'm going to do is just multiply the last few things that I need to multiply to get my expansion. Well, part of it, because I still got to do one more thing. So it's going to be 1 minus x over 4 plus 3 30 seconds x squared. Then minus, what's 16 times 8? 5 over 128 x to the third. And that is 1 plus x over 2 to the negative 1/2. So there's something else that I have to do before I can actually get my full expansion. I need to multiply by that constant on the outside, okay? But I don't want to work with a negative fraction, so how can I rewrite 2 to the negative 1/2 as a non-negative exponent? Square root 2 over 2. Square root 2 over 2? Because this turns into 1 over 2 to the 1/2. That converts to 1 over the square root of 2. And then, of course, rationalize the denominator. You remember that? So my final answer for the expansion is going to be the square root of 2 over 2 minus the square root of 2 over 8x plus 3 square root of 2 over 64, x squared, minus 5 square root of 2, 256?
Yep.
Over 256, x to the third. Questions? Now the interval's not bad as long as you remember what the formula is, okay? Because it's asking you to state the interval of conversions for the complete expansion. The formula goes from negative, is it a over b or b over a? A over b less than, or is it less than or equal to? X less than absolute value a over b, like so. So really all you need to know is what your a is and what your b is, take the absolute value, whatever that fraction is. Okay? What is a in this problem? Or what's considered a in this problem? 2. And you get that, okay, from back up here, you know, like the non-pulled out form. You get it back from this one up here. Okay? So this is a, and b is going to be, which is 1. Because remember, it's bx, so the constant's 1. So a is 2, b is 1, so this becomes the negative absolute value of 2 over 1 less than x less than the absolute value of 2 over 1, which is nothing but what to what?
Negative 2 is less than x, which is less than 2.
So as long as x falls in between negative 2 and positive 2, then your expansion is going to converge to one particular number. There was actually a part C to this which actually asked you to find an estimation of 1 over the square root of 2.1. X is technically in between that interval, so it would converge down to a number. Okay? And I held that one off because we did one like that in our problem of the day. Questions?